Hello, Cho. Sat Sri Akal and Namaste from my side. So this is your own physics educator Indrajit Singh welcoming you all into the ultimate recap. Right? Ultimate recap for the students of 12th. As this is being the first lecture, I'm not going to discuss the entire electric charges and field. No, it's not like that. I'm only going to discuss the separate part. Okay, it's not about the electric charges and field, the entire thing. For this lecture, right? Let's divide this lecture into the multiple parts. I have a conversation with team. Okay, for this lecture, right, we will only discuss the fundamentals and we will be comfortable with each other. Okay, because overloading all of those students with the very first lecture, it is going to be quite injustice with you all. Right? It is injustice with you all. Okay, so here we are going to approach the same way. So I think without wasting our time, I'm going to move forward. What will be the agendas of today's lecture? Right, it will be recap. The recap of the fundamentals. Right, recap of the fundamentals. And without wasting our time, we are going to begin it. Okay, so let's start with it. So here, right, what we are going to do, rub the balloon, okay, on a jacket. Obviously, it is a winter, right? So I've rubbed. Now see what happens. What is going on? Now suppose if we are bringing this to the near to the wall, you can just analyze all of those negative charges. See the variations. And now suppose I am going to release it. Arey yaar. Got stuck. Now, what is an actual logic behind it? Yeah, so you have to just wait for that. But suppose if I'm again refreshing and like I'm taking up the two balloons. One, I've rubbed with the jacket. Second, again I'm trying to rub it with the jackets. It gets stuck everywhere. If you want to place it individually, it's okay. If you want to get near to the positively charged body, it's okay. If you want to keep near to the negatively charged body, it's okay. Many students might be into the thought, sir, it's a physics. Again, we are going to start a syllabus of the 12th. And what kind of the unnecessary thing is going on? Okay, so guys, this is how we are going to study in physics. We are going to start the lecture with the, what we can say, we are going to start the lecture with this all stuff, the simulations. Physics is like that, it should be represented well in front of the students, and as of Saul, Alak sir also used to say, the one who is not able to teach that physics into the right, most appropriate manner. In a simple sense, the common message to the all, we have to represent that thing into the most innovative way, into the different way, so that it seems to be. Basically, its subject was not interesting as what we all are thinking, because we always are judging the cover by its book. But it should be represented in the, like, suppose let us take an example, right? Cheese burst pizza, taken a slice. Wow, the cheese is stretching. No, that's a cheese burst pizza. You all like that, but that is represented well. Right? So physics is that kind of the subject. It should be represented well so that students will get okay. No student might have understood what we did right now. But it was important to show the simulation. The reason behind it was, now when I'm going to explain the each and every part of it from the syllabus point of view, right? Slowly, step by step, things are going to get settled into your mind. Okay. So many students are aware of all of these examples. This is a static electricity. It happens, right? Even we are going to rub the balloon by the head, then it always gets stuck on the wall. It is a day-to-day life routine. Yeah, many might be aware of, some might not. But the thing is, from the syllabus point of view, right, how we are going to correlate the day-to-day life. See, physics is all about whatever the going on, whatever the things or activities going on into the nature. We are analyzing it. We are writing down on the paper. We are representing that into the mathematical form. That's it. Physics is all about that. Right now, I am saying the boy is moving on with some speed. Okay, he's having KTM. Right. So right now, object is in front. I am an observer. I am analyzing any activity. Right. His bike is getting continuously accelerated. So I analyze that activity and write down into the paper. It is the case of the non-uniform motion. This is the thing going on, na? Right? So physics is all about the maximum about the day-to-day activities. Okay, for each and every part, we are having an example from the day-to-day life to understand and to correlate it with the syllabus. Okay? So this is going to be the first lecture of the 12th, and the scenario of the physics is going to change. Till now, you have seen motion, you have seen units in measurement, you have seen NLM, you have seen work, energy and power, you might have seen rotational motion, many might be into the dot. Nothing I have seen. Coming, going. Okay, so sometimes it is our fault also, huh? All the time it is not the fault of a physics, right? Okay, somewhere if we are facing in sarcasm, so it means something is lacking in you all that we have to recover and we have to buckle up ourselves. Okay, so we are going to start a new thing. I kept a simulation in front. The one who is going to be till end of the lecture will definitely get a final overview what this simulation tells us about and how we are going to correlate that to the specific part of the syllabus. So you have to pay attention here till end. And obviously the new syllabus is going to start. So today we are not going to do a lots of things. No. Today we are just going to be comfortable with physics. Right? We have to be fine. Just be comfortable with physics. Okay, it's not important that everything we are going to do today. No, today just be comfortable with physics. Sorry. Now, we are going to start the new branch of physics, that is electrostatics. Right. Why I am saying this? It is important to understand. Right. Why I am saying this? It is important to understand this word. If you are not able to understand this part now, right, it would be quite difficult to get right yourself fundamentally correct in terms of logic. Okay, if you're not going to understand this word now, it would be right quite incorrect. It would be quite, you can be fundamentally wrong in understanding the logic from this specific chapter. Okay, so first of all, if I am going to tell you all about the syllabus of the 12th, then it is designed like electrostatics, right? And there comes the capacitance, and there comes the current electricity. And here comes the part of magnetism. First, electric field and electricity is going to come, then magnetism will come. Then the relation between, okay, electromagnetic induction AC, right? Optics and modern physics. Okay, this is how the syllabus is designed. First, electricity and electrostatics part will come, then magnetism will come, then relation between the electric field and magnetic field on the basis right? Then we are going to change the supply from DC to AC. Okay, and then a new domain, optics, is going to come, and modern physics. So the syllabus of the 12th is designed like that way only. Okay, like syllabus of 11th. First, motion, only particle and observer. Slowly NLM, particle to object having mass. Observer is also changing its position. Slowly energy, particle with mass, changing its, observer is changing its position, and now energy is included. Now rotational motion, particle is considered having the mass. This is the journey from particle to mass, na? And then again rotation, it is included. Generally we were not considering till work energy and power, no rotational effect was considered. Okay, and in rotational motion suddenly we introduce the configuration of the body and center of mass. Till work energy and power, no configuration of the body was considered apart from some sums, right? And suddenly comes gravitation. So this is how the entire mechanics is designed. Again, after that they comes on the solid part and liquid part and the gas part, thermodynamics and everything. Then finally they get reached up to the waves, the SHFN waves. Okay. So this is how the 12th syllabus is designed. Okay. Now we are directly going to focus on this part. Okay. I'm going to just cut it up. Okay. What does this word tells? What does this chapter tells? Before moving on, before starting on an every chapter, right? There is a fundamental logic behind it. There is a cover of the book. There is a fundamental thought behind it. So we are going to discuss that thought. If you are going to keep this thought till the end of this chapter, you are not going to face any problem with it, right? Electrostatics. It comprises of two words, electro and statics. Statics, it means that they are talking about something that is stationary. Statics means that they are talking about something that is completely stationary. Electro, it means that they are talking about the something that is having an electric effect, right? Okay. The combination of these two, it is nothing else but the electrostatics. Now many students might be into that also, how it is so possible that the static, the anything. I'm not discussing that who is stationary. I'm not going to discuss that who is stationary and going to give the electric effect. No, we are not aware of. Okay, here it might be body, here might be charge, here might be anything. We are not going to discuss onto that part. But right now, as a food of thought, something is stationary and giving the electric effect. Baba. We have seen into the simulation. The jacket was stationary, but it was showing the electric effect. Balloon, initially it was stationary. We moved it, right, and we rubbed it on the jacket. After it was kept stationary, it was getting attracted to the jacket, but finally it was stationary, na? It was showing some electric effect. Previously balloon was not showing the electric effect, but when it was rubbed, okay, then suddenly it changes its behavior. Okay, now things are gonna get weird here. Why this happened? We have to understand the logic behind it. We have to understand the logic behind it. Okay, so the word itself states that electrostatics, some electric effect, some stationary object or a particle that is giving an electric effect, right? In another terms, it is also known as, or it is also defined as static electricity. Now here comes the second thought. If it is an electrostatics, something is stationary and giving the electric effect. What will be the most appropriate reference particle to understand this concept? As of that reason, charge is taken. Why? Why? To understand the concept of the electrostatics, this charge is taken as a reference and all of those theories are defined on the charge, because charge is nothing else but the fundamental. What kind of the fundamental thing and where? For all entities in universe. If anything is defined into the physics, then it should be defined right fundamentally. So if you want to define anything fundamentally, then for that you need a fundamental particle. Na? So for that reason, right, whenever this electrostatics branch started, okay, they consider that a stationary particle is showing some electric effect. So to understand all of those concepts related to the electrostatics and static electricity, we need a fundamental charge. We need a fundamental particle. Now in the entire universe, all of those entities, those who are present, are made up of the fundamental particle, that is charge. So as of that reason, the charge is taken as the reference to explain all of those concepts and theories. Scientists took, okay, they were unable to explain, okay, they were really unable to explain. Suppose if you want to explain the electrostatics, they were unable to explain by taking a single identity as an example. Why? Because it is not going to be the universal, na? Things are not going to be universal. But here all of those laws, that they are applicable universally. So as of that reason, to explain all of those concepts into the one shot, we need a one reference particle. So for that, this fundamental particle charge is taken as the one. The fundamental particle charge is taken as the one. Okay, I'm going to keep on this AC, else this room is closed. I heartily apologize. Okay, so hope so you all understood the example of the electrostatics. Okay, so in this chapter, what is the food of thought? In this chapter, we are only going to understand all of those concepts related to the stationary charges, whether it is force, electric field, Gauss law, flux, everything we are going to see. In some of the cases, right, there is a possibility that may come, okay, the motion of the charges, but in that, okay, we are going to have some restrictions, and then I'm going to discuss into that specific part. Okay, so right now you all should have a food of thought. Stationary charges, we are going to understand all of those concepts based on the stationary charges. Again, many students might be having a thought, sir, bluffing, you are bluffing. Still you didn't correlated that simulation that you played in front, okay, to the concept. Beta, it is a web series kind of thing. Please don't consider this batch as a batch. Consider it as a web series with the multiple episodes. Okay, you all are seeing the Game of Thrones, right? Okay, so this batch is kind of the web series. First of all, before introductory section 1, suspense comes. So that acts like a simulation. And after that, intro will come. Hello, bacho! And after that, the main content will come, and then at end, suspense will get revealed. Episodes by episodes we are moving. Episodes by episodes we are moving. Slowly, things get changed. Okay, so this is nothing else but the web series you are watching, and right now, okay, one person is acting in front. Okay, and what is the pattern of the web series? First, they will give you a suspense that this thing happens. After that, story continues, episodes by episodes, and slowly, when the last 3 to 4 episodes remains, okay, and then slowly, that suspense is going to reveal into the multiple parts, and finally it ends. It ends like a question mark. What is going to happen? Next series is going to, yes, next. Okay, so this is all about the electrostatics. Now, we are going to deal with the charge. We are going to deal with the charge. Now, what is an electric charge? Right? If I am talking about the most common definition of the electric charge, fundamental particle of any system. Fundamental particle of the any system. That I'm not moving on to Deichmann technical definition. Not moving on to the Deichmann's technical definition or something like that. We are not going to move forward. Don't get frightened. Right? I'm not going to move forward. Okay, I'm not going to discuss that part. Okay, right now, just to be comfortable, In easy language, what is charge? In easy language, what is charge? So simply we are defining the charge as the most fundamental particle of an entity of an system. Most fundamental particle. Right. Okay. Most fundamental particle. Now, if you want to understand the charge better, then the most, right, you want to be the friend of the electric charge, then you need to understand the classification of the charge, where it is present, what kind of the effect charge is showing. Okay, simply if I want to define this charge, I stated in front the fundamental particle, the smallest, the tiniest, the fundamental particle of the system. Suppose if I'm talking about, let's take an example to understand this, right? Okay, if I'm talking about the table, now many might be saying, sir, one leg missing. Yes. Okay, table is like that only. Okay, I'm having the missing leg. Okay, the most fundamental particle of which the table is made of, most fundamental particle of which the table is made of charge. The first example coming in front. If I'm talking about the second example, okay, if I'm talking about the second example, the most common thing that you are using into the day-to-day life, right? Your infinite display mobile phone, smartphones I'm talking about. Have you ever heard of how this touch panel works? Have you ever thought, right? Just Google out the logic behind it. You will definitely understand the definition of the charge. Okay, how this touch panel works. Okay, it is completely based on the position of the charge and the combination of the position of the charge and the Cartesian coordinate system. Suppose if you are going to touch this point, then system will get an access. This position of the particle, of the fundamental particle, got disturbed by touching. So we have to act like that. Suppose if you want to get click to the messages, so at that position, whatsoever the disturbance that is produced, okay, that will give an idea to an operating system behind the mobile. You have to act accordingly. Okay, right. So is it charge present on this? Yes. Is charge present on the mobile phone? You sir, you said na fundamental thing. It should be present everywhere, na? If it is a fundamental thing, you only told na, sir. You only told na, in all of this entity present into the universe, the charge is, right, is a fundamental particle. So that's why the scientists, all of those scientists have taken the charge as a reference and they're explaining all of those concepts. Right. If I'm talking about the third example, right, if I'm talking about the third example, the piece of the cloth, is charge present? Sir, fundamental you told. It means there is a possibility. So let's prove how. Right, let's prove this how. Charge is present everywhere. Basically, if I'm talking about the charges, then the classification states that we are having the two type of the charges. The one that is a positive charge, right? The second that is a negative charge. The one that is a positive charge, the second that is a negative charge, right? The one that is a positive charge and second that is a negative charge. Now, how charge is present everywhere? Okay, and if it is present, you told us, sir, charge statics, showing electric field, showing some effect. Static charge showing effect, electrostatics. And charge is also fundamental particle present everywhere into the universe. Then why touching on this smart board, we are not able to feel that effect? Right? Charge is present everywhere. Okay, in all entities of universe, charge is present everywhere. In all of those entities into the universe, charge is present everywhere. But why we are not able to feel that? Why? Because all of those bodies are neutral bodies. Now many might be into the thought, sir, first you told us electrostatic, the definition of electrostatics. Now you grab us all. Okay, first you told us the definition of the electrostatics, and after that you grab us all to the definition of the electric charge. Now we are drifting, you are drifting us towards the classification of the charge. It is a classification of positive and the negative charge. Now you are saying neutral. Apart from neutral, something apart from this exists, sir? Question. Slowly we are going to into the deep, right? In today's lecture, we are only going to understand the properties of the charges, right? The charging techniques, so that tomorrow we can start by the Newton's law of Newton's law. Okay, so today are the fundamental things, the properties, the conservation law, okay, and all of those stuff we are going to see. Okay, we are going to see numericals also based on that. Okay, because lots of awesome numericals from this. There has been asked in NEET also and JEE also. But being a dropper, those from this fundamental thing, the questions have asked as a PYQ, right? Okay, we are going to see that also. But you need some patience. You don't need, but you should have some patience regarding. Okay, so charge is present everywhere, in the smart board, in this camera, in me, in the front of this TV, in this right curtains, in this AC, in this light. But when we are touching those, why we are not feeling that? Because those all are atomic neutral bodies. Now many might be into the thought, what is an atomic neutral body? Again the new classification came. Okay, slowly we are going to deep, right? So basically 3 types of the bodies are there. I'm going to give you all the example, right? Types of bodies. I am having the habit to write, okay, from this side to from right to left. Okay, if any student is having the problem, they can comment. Okay, please don't get worried. All of those notes are available. You are going to note all of those mandatory things. But if at any position of the time you feel uncomfortable, okay, just do, okay, text beneath the video. Types of bodies. First, that is atomic neutral body. Now what does this tells us about atomic neutral body? Okay, suppose this is a specimen I am talking about. Why this specimen is considered as atomic neutral? Because it contains the equal number of the positive and negative charges present within itself. 4 number of the positive charges, like that 4 number of the negative charges are present. Especially it's not 4 or 4 like that, but 4 number of the positive charges and 4 number of the negative charges are present. Okay, 4 number of the positive charges and the 4 number of the negative charges are present, right? Okay, now in this case, specifically I am thinking 4 number of the positive charges and 4 number of the negative charges are present. Now see, mark my words. Number of positive charges, number of negative charges. Generally, for a reference, proton will be considered as having the positive charge. Electron will be considered as the negative charge. See, body possesses the charge and then it gets the nature. Positive charge means all times proton? No. Proton is a particle that possesses the positive charge. Electron is a particle that possesses the negative charge. So there is a difference, you have to mark it up. Right? There is a difference that you have to mark it. So atomic neutral body right now is a reference particle, as a reference positively charged particle we are considering the proton. And as a reference negatively charged particle we are considering the electron. So here the number of the protons and the number of electrons are equal. That's why this body is atomic neutral. The smart board is atomic neutral, the wall is atomic neutral, this camera is atomic neutral, the camera in front is atomic neutral, the TV in front is atomic neutral, this AC is atomic neutral, the lights are atomic neutral. Why? They all contain the equal number of the positive and the negative charges, right? So the effect gets nullified. Suppose by any way, we are going to disturb this arrangement, then two more bodies are going to evolve. Positively charged body. Okay. Again, for that we are going to take one specimen in front. Okay. Again, we are going to take one specimen in front. Positively charged body, it means that number of the positive charged particles are more as compared to the number of the negative charged particles. Number of the positively charged particles are more, right, as compared to. It means that in reference statement I can say number of the protons are more than the number of the electrons, right? Number of the protons are more as compared to the number of the electrons, right? So that's why it is known as the positively charged body. And yeah, while teaching, we are teaching in front of the camera. So generally this happens. I'm having a habit, okay, all the time to speak okay or right. So please guys, don't feel irritated as of it, okay, because we are going to teach into the pure English mode and no physical students are present. We are teaching virtually. So it's like if I'm taking a 1 hour of lecture, okay, I'm taking a 1 hour of lecture, then all of the time I'm going to speak in front of the camera without any retakes and everything. So it feels like, na, sometimes we use some words multiple times and it becomes our habit. So please don't get irritated because of it. Just happily comment. So please don't use it and we'll cope up that. So atomic neutral body, positively charged body, and the third type of the body, that is a negatively charged body. Now I'm not going to explain that much into the negatively charged body, right? Why? If I'm taking on specimen, right, the number of the negative charges are more as compared to the number of the positive charges. Number of the negative charges are more as compared to the number of the negative charges. So number of the protons are less than number of the electrons into the reference statement. Okay, so basically these are the three types of the bodies. The first one, that is an atomic neutral body, right? The second one, that is a positively charged body. The third one is a negatively charged body. Atomic neutral body, into the reference terms, proton is equal, number of protons is equivalent to number of electrons. Positively charged body, in reference statement we can say number of protons is greater than number of electrons. Third one, negatively charged body, in reference statements we can say number of protons is equivalent to less than number of electrons. Right guys, if you want to just note this down, I'm moving aside for the 10 seconds. You can take your time and do this stuff. So it's 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. The types of bodies we have seen. Now, I told one statement. Some might have noted that, well, some not. How this happened? I gave a statement that all bodies are atomic neutral bodies. All bodies are atomic neutral bodies, and how, what kind of the process it went on that this atomic neutral body got converted into the positively charged body. What process went on in which the atomic neutral body got converted to the negatively charged body. Okay, so here comes what happens to, right, to the bodies that they are changing its state. Right, what happens to the bodies that they are going to change its state? And here comes the charging techniques, right? Charging techniques. I'm going to take the very simple example of the day-to-day life. How the bodies are getting transformed from the atomic neutral body to the positively charged. how the bodies are getting transformed themselves from the positively charged body to the negatively charged, or from the atomic neutral body to the negatively charged, or the vice versa. So here comes the charging technique. See, slowly we are grabbing. We started the new things, electrostatics. We saw the simulation suspense in front. Now I am going to teach you all how the simulation is going to help us in understanding the charging techniques. Right? In understanding the charging techniques. Okay. See, slowly, first of all, electrostate simulation, and then electrostatic, then fundamental thing, electric charge, then types of charge, then types of bodies. Now, after this types of bodies, we are going to move forward for the charging techniques. And after that, we are going to see the properties of the charge and some of the sums, and we are going to end up this lecture. Okay? Some of the sums, and we are going to end up this lecture. Okay, hope so. I have served fruitfully, because the entire syllabus of the 12th we are going to spend ourselves with. You all are going to spend with me, right? So please, if you are having any kind of the thoughts, you can, else you can, okay, whatever you want to do, you can. It's okay. So now, charging techniques. Basically, three kind of the charging techniques are there. First one, it is conduction. Second, that is induction. The third one, that is friction. If I have to gesture these three techniques, see, I am having the capability to explain all of those three techniques in 1 second with a simple gesture. And you will understand also. You will remember also. But the question is how? These three techniques are correlated with each other. This is a gesture. Induction, conduction, friction. Three charging techniques are there. Induction, conduction, friction. First, I'm going to give you all the example into the day-to-day life. Then we are going to compare this with the simulation. Now, what is conduction is all about? What is this conduction is all about? Charging techniques, it means that somewhere the bodies are whether getting positively charged or negatively charged. Conduction, for charging the bodies, right? For charging the bodies, physical contact is needed. For charging the body, right, the physical contact is needed. If you want to charge up those bodies, in between the two bodies, suppose these are the two atomic neutral bodies. If you want to charge it, physical contact is needed. Physical contact is needed. No, don't get worried. I'm going to give you all an examples of it. Okay. First, day-to-day life examples, then simulation, then technical examples. Okay, in terms of the syllabus. Three type of examples I'm going to say. So conduction, for the charging, physical connection should present. Induction, no physical contact needed between the bodies. No physical contact needed in between the bodies. Induction. Rubbing is done between the two bodies. That is, as because of the friction, the bodies get charged. Let's take an example. Mom, son. Mom, guest starts going to arrive. You have to immediately move on for the supermarket and buy some stuff. And we are पतली कमरिया मोरी आए हाय तिरछी आए हाय. Guests are going to arrive, immediately move on for the supermarket and buy some stuff. पतली कमरिया मोरी. Guests are going to arrive, immediately move on for the supermarket to buy some stuff. पतली का. Now mom took Rodra Swaroop. I said na, physical contact is needed for the charging. After this physical contact, immediately you are going to get up. Ha, mummy, going na supermarket to buy some stuff and come back. There exists a different kind of mom. So mom is everything, but the prakop, the effect of the presence of the mom tells you everything. She needs a physical contact. I told you all, move on to the supermarket. The guests are going to arrive and buy some stuff. Now your kamar will be not patli. And your najar will also not be tirchi. Induction. Physical contact is needed. Induction. Mom is only going to, I told you na, go to supermarket. Yes, mama. She have to just show her presence. Immediately you are going to move to the supermarket and whatsoever you are going to buy. Even this time you are going to buy those things that is even not needed for the guest. This thing happens now. There is a difference. Conduction, induction, friction. Friction, the rubbing of the two charges. So this is a day-to-day life example. Okay. And one, rubbing is needed. In the second, physical presence, no physical contact is needed. Mom is just showing her enough chappal. Go. Immediately. And we are moving forward to the technical example. Right? Conduction, induction, friction. Okay, first. This is the atomic neutral body. Right? And this is the body that is having the, suppose let us take an example, this is having the body that is having the 4 coulomb of charge. This is the body that is having the 2 coulomb of the charge. Now they are brought in contact with respect to each other. Brought in contact, it means physical touch is needed. So what will be, when they are brought in contact with respect to each other and again kept at some distance. So what will be the final charge? Right? 2 plus 4 by 2, right? 2 plus 4 by 2. Okay. So the final charge on each will be 3 coulomb. 3 coulomb. Conduction. Induction. Okay. Suppose, or if you want to take this example, you can take also that this is an atomic neutral body. Okay. This is an atomic neutral body. Okay, suppose this is an atomic neutral body and they are brought in contact with respect to each other. Right now it is not having any current, the net charge is 0. Now when they are brought in contact with respect to each other, right, then 2 divided by 2, 2 divided by 2, so each of the body is going to get 1 coulomb. So previously it was uncharged, now it is having the charge of 1 coulomb. So when they are brought in contact with respect to each other, the body got charged na. So this is a conduction technique. Okay, this is the conduction technique. The second one is induction. Induction is very simple. This is an atomic neutral body that is having the equal number of the positive and the negative charges. If I am bringing a negatively charged rod nearer to it, just nearer to it, what is going to happen? All of those positive charges present into the body, all positive will attract towards rod. And suppose if I am going to earthen this, then all of those negative charges are going to flow into the earth. All of those positive charges are getting attracted towards the rod and all of those negative charges are going to be into the earth. Now suppose if I am keeping the rod away, there will be only positive number of the positive charges into the body and hence the body became the positively charged. Okay, so this is one of the technical examples of the induction. The third one states that friction. Okay, glass rod with the silk cloth, right? This is a very famous example. Okay. The most important thing is that with charge transfer, Mass transfer also takes place. Right? With the charge transfer, the mass transfer also takes place. Okay, on basis of this statement, lots of questions are going to come up into an examination, are coming up into an examination. So basically, these are the three kinds of the charging techniques, and after that, we are going to move forward, right? After that, we are going to move forward to the basic property of the charge and the law of conservation of charge. The law of conservation of the charge states that you all are aware of about the law of conservation of charge. Charge is a fundamental particle. It can be created, can't be created, not it can be destroyed. Only it can be transferred. Energy can transform. Charge can't even transform themselves. They can only be transferred from one point to another point. They can't be created, they can't be destroyed. This is a law of conservation of charge. Right. Now we are going to deal with the properties of the charge. And we are going to see some of the sums based on it. Basically, three types of the properties are charge. Sorry, three types of the properties are there. Additivity. The additivity of the charge states that the total charge on the the total charge on the body is algebraic sum of the individual charge, is equivalent to the total charge on the body is the algebraic sum of the individual charges, right? So it means that if I am going to calculate, right, the total charge on the body, or you can say the charges can be in summarized form. If I want to tell you all, charges can be algebraically added or subtracted. Algebraically process, algebraic phenomena can go on with the charges, right? Suppose if I'm talking about one system that comprises 2 coulomb and 3 coulomb, what is the charge on the body A? The total charge on the body A, that is charge on 1 and charge on 2, right? So it is 2 coulomb plus 3 coulomb. The total charge is 5 coulomb. Yes, the charges can be algebraically added. Second, that is a quantization of the charge. What does this quantization states? The charge on the system can be integral multiple. Charge on system is integral multiple of the fundamental charge. It means that they are saying that value of charge can't be fractional. Okay, the statement states that Q, that is equivalent to N of E, right? N can be the whole number. It can't be the fractional value. The value of the E, that is the value of the fundamental charge, that is 19 coulomb. The coulomb is a unit of charge, right? It can't be, any body can't be have, right? The value of this N can't be fractional. It should be into the multiple of E only, 2E, 3E, 4E, minus 5E, minus 4E, whatever it should be. But it should be into the multiple of E, that is quantization. Third, we are aware of conservation of the charge. Right? Third, we are aware of conservation of charge. Right? This is a very popular statement. Charge can't be created, can't be destroyed, only it can be transferred from one point. Okay, nor they can be transformed. Okay, at any point of time, if you are feeling that you are not able to understand my language, you can ask into the doubts. I will answer all of those stuff, right? You can ask into the. So these are the basically three properties of the charge. So students, first of all, right? Thanks a lot, right, for this cooperation and the time you gave. It was very short lecture, I can understand, but you might have enjoyed. So I'll be waiting for all of your comments beneath the video, right? So this is your own physics educator Indrajit Singh signing off from the desk. Bye bye. Sat Sri Akal and Namaste from my side. Bye everyone. Stay at home, stay safe, stay healthy amidst this pandemic, and take care. Bye.